Hi friends, welcome back to Interactive Schooling. In the previous video, what did we learn about? We learned about cathode and anode rays, which led to the discovery of electrons and protons. So they discovered these two subatomic particles, that is electrons and protons. So using the knowledge of these two subatomic particles, they tried to propose some atomic models, what an atom looks like. So as I always say, if you have not watched the previous video or if you don't know the concept, just go and take a look at that video so that you get a continuity on this one. So they discovered the electrons and protons, and with this they proposed some atomic models. The first one was J.J. Thomson's plum pudding model. So this was called the plum pudding model because what does a plum pudding look like? It's like a cake and it has plums or raisins or something embedded in it. So this is what his model was. A sphere of positive charge, which is the proton, and this had negative charge embedded in it, like this. So the charge of the negative charge was equal to the positive charge, which explained why the atom was neutral, and the mass was uniformly distributed throughout this atom. So the proton's mass is 1 AMU. What is AMU? 1 atomic mass unit. So proton's mass is 1 AMU and the electrons is very negligible. So it's considered as 0. We don't take that into account. So this was J.J. Thomson's plum pudding model. Later, a scientist called Rutherford, he did an alpha particle scattering experiment which led to the discovery of the nucleus. So what he did was, nucleus was discovered by Rutherford. What he did was, he took a thin gold foil. Thin means don't take like this much or something. Its measurement was 10 to the power minus 6 centimeter. That is 1 millionth of a centimeter. It was that thin. And why he chose gold was because of its malleability, high malleability. What is malleability? It's the property of a substance to be beaten into thin sheets. So gold is a highly malleable metal. That's why he chose this for the experiment. What he did was, let's say for example, this is an atom of the gold foil. What he did was, he scattered some alpha particles. This symbol denotes alpha, it's a Greek letter. So alpha particles, what are they? They are helium dipositive ions. So helium is the second element, and if you remember in that pure or impure substances video, we had learned the classification of elements: metals, non-metals, metalloids and noble gases. Not gases or noble gases, they are unreactive. Helium is also a noble gas, but what they did, they somehow removed the electrons from it. Okay, they removed the electrons and this He2 plus. It has two, actually, what does an helium atom look like? It is like this. Since its atomic number is 2, atomic number is equal to number of protons is equal to number of electrons. So it has 2 electrons and 2 protons. When they removed these 2 electrons, what happened? There are only 2 protons here. So there is 2 excess positive charge. So it is He2 plus. We learn more about this thing after this video. So he scattered some alpha particles here. So obviously these alpha particles are positive in nature. So what he did, he sent some alpha particles like this. So when these, like, they went here, some just passed through. Some passed through like this. Some of them, they were deflected at very large angles like this. And very few were directly sent back. They went and they were directly deflected back. So from this, what he concluded was that an atom had a nucleus which was positive. Because the alpha particles are positive, right? They were repelled by this nucleus. So he decided that this is positive. Like charges repel each other, right? So when positive goes near positive, it gets repelled. So he concluded that an atom has a nucleus which has all the protons, and around this the gaps are huge. Okay, around this there are orbits in which electrons revolve. So his was called the solar system model. One more thing is, all of this is, that's one thing. Like this, around this there was a zinc sulfide screen. He used this for, as we know, these anode, they produce fluorescence, or anode rays, they produce fluorescence on the zinc sulfide screen. So something related to that topic, for that he had kept this zinc sulfide screen. So coming back, his model was called the solar system model. Because his was very similar to that. It was like one positive, the protons were inside the nucleus, and in orbits, like electrons, these revolved like this. So this was his model. But sadly, his model, of course, this discovery of the nucleus was highly appreciated, but this model was rejected because it did not satisfy some facts about the atom. One thing is, if it's like, if the electrons are revolving here, they should lose some energy, and at one point their orbit will just reduce and reduce, and at one point it will just crash, right? This electron slowly loses energy, and it goes like this, and it goes and crashes in the nucleus. So that was what the people's doubt was. But as we know, an atom is stable. If the electrons go and crash in the nucleus, then the atom would spontaneously burst, right? So they rejected his model. Later, a person called James Chadwick, what he did was, in beryllium, in a beryllium atom, that is mass number 9 and 4 protons and electrons, he bombarded it with some alpha particles, and that gave carbon 12 and 1 neutron. So this had some 1 AMU mass, and it was electrically neutral. So they discovered another subatomic particle called neutron. So then Niels Bohr, what he did was, he proposed that an atom looked like this. This was a nucleus with neutrons and protons, and the electrons, these orbits were called energy levels. So while rotating, the electrons did not lose any energy. They did not lose any energy, and when actually there was no change, but if in case they gain energy or something, if they gain energy, they'll go to this next one, and if they lose energy, they'll go to this previous shell. So that was his theory, and there were like nucleus. So this first shell was K, second shell was L, third shell was M, and fourth shell was N, and so on, or 1, 2, 3, 4, so on. So this was Niels Bohr's atomic model, and this is the one that we follow right now. So that's all for today's video. I hope you understood how we have come to this final conclusion of ours, what we hope is correct. So in the next video, we will concentrate on isotopes and isobars. So until the next video, goodbye friends. Do like, share and subscribe to the channel.